several kids out. I forgot all the way until that stage there. And then I'm going to hit graph, and I'm going to take a look at the graph. So once I type the equation in there, I'm going to hit the word graph. Woohoo! Yes, that did open down. I was thinking it was because there was a minus in front of the parentheses, so I was thinking that was opening down. So now I'm going to do second graph to get to the table, and I'm going to cheat, and I'm just going to grab the numbers from here to just fill in my table real quickly just to save me some time. And 7, 6, and 3. Okay. Now, if this was the non-calculator portion of the end of course exam, then you'd have to. They wanted you to fill out a table. Then you got to use the Vertex, pick the numbers like I did, plug them in for x, and start simplifying. Put the -4 in. Say -4 plus 2. -2. -2 squared is 4. Now make it negative because there's a negative out front. -4 plus 7 is +3. So they expect you to be able to do that by hand with, please excuse my dear Aunt Sally skills. My domain. So now let's go back to the graph. I see where it's at. All right. Got some crazy x-intercepts. They're decimal x-intercepts the way that's looking. So, but I do know the vertex as I go to sketch the graph. I do know the vertex is -2, 7. So over 2 to the left, up 1, 2, 3, 4, 5, 6, 7. So there's my vertex. There is my -2, 7. I see that I do have a y-intercept in my table, 0, 3. So I know it does cross the y-axis at 0, 3. And then now I know there's another parallel point at -4, 3. So when I look at trying to make this as pretty as I can, and then now I'm just going to carefully go down to sketch, carefully go down to sketch, something like that. Not worried about the precise x-intercepts, they're decimals, but that at least gives us a good idea using two nice ordered pairs from the table. We could have used the -3, 6 and the -1, 6. That was fine. Domain and range. Another thing we always got to be thinking about no matter what the function is. Does it matter what x value I put into a quadratic function or the x squared function? No. Based on our parent function days, our domain is -infinity to +infinity. Or like some of you put down, all reals. Okay? Now, the range is what y values are being used. Are we using everything up vertically? No. Is there an absolute bottom or absolute top? All right, what's that top? 7. So I don't go. So 7 is the after the comma. I don't go up past 7. And technically it's a square bracket because we go through that point. And then I notice both sides are pointing down to the ground. So -infinity is what's before the comma. And then we just make sure that there's a curved parenthesis on the -infinity. We are going to be asked to do domain and range for all those parent functions I introduced to you a couple weeks ago. Okay? All right, number 3. Again, you can work ahead of me. Yo, Will.
Yeah, mine would go like graph.
Yours won't graph?
Yeah. They go like
Oh.
this table.
It won't graph a picture? You know why? It's because last time you used that was the linear regression, so it had the scatter plot jump and we were zooming for that line. That's right. So, yeah. What's up? Okay. Yeah, it's probably, so you probably have your stat plot turned on. So let's do second y equals. And then hit enter. And then toggles off. Okay, and then now if you hit graph, then we're going to have to change this. So zoom 6. That gives you the standard 10 by 10. The equation 11. You got something crazy in there. It's like taking forever to do. There we go. All right, all right. All right. So I'll catch up to you. Number 6. Let me find my pen there. All right. So vertex 1, 0. And that is one big tip of a stinking pen there. All right, axis of symmetry. X is equal to 1. We're going to draw that on the next this problem here in a second. Now, I know 1, 0 goes there. Again, I can start grabbing points 0 and -1, 1 and 2. I'm going to go ahead and cheat and use the calculator to get the table real fast for me because I got better things to do. It's Wednesday night. It's church night. So we got to get done quick. All right, and we'll go in here to y equals, and I change that to be 3, and then it's x minus 1 squared, and get rid of the plus junk at the end. All right, that looks pretty good to what we have there. I hit graph, and then I'm going to hit second graph to grab my table. So at 0, we had 3. At -1, it was 12. And then we'd have at 1, I did the 1 twice. Did you guys notice that? I did that 1 twice. And 3. There we go. At 2, it was 3. And at 3, it was 12. And again, should it make sense that we're repeating certain y values? Yeah, because it's a u. We should be, as we go out horizontally left and right, we should be repeating y values. So it shouldn't be a surprise that I see the 12 listed twice and the 3 listed twice. So now as I go to graph that, this thing opens up. Again, you had the picture, but 1, 0, it went through 0, 3, also goes through 2, 3. All right, so there is my skinny. I can't get up to 12 for the other order pair, so that's why I chose those. There's my skinny u. Should it be skinny? Yeah, why? Yeah, we had a vertical stretch, didn't we? That little 3 right there told me I had a vertical stretch. So that means I should be skinny. So it should be, tall and skinny as we look at it. My domain. We're allowed to put everything in there. Negative infinity to positive infinity. And then my range. Are we using up everything vertically? No, there's an absolute bottom, isn't it? All right, the absolute bottom has to be where y is what? 0. So we go from 0, we point up to heaven. So from 0 to infinity would be my range. Again, as I was looking at, and I'll push it out to you because we got all the tests done. I'll push out and let you be able to look at what you missed and all the problems and the correct answers. Some of you, as you were filling in some of those things, were looking at the right ordered pair, but you grabbed the wrong value to put in for either the part of the domain or range. Okay? Yeah.
Why is it 0 like the first one? This one is like the 7 is the 6.
Well, good question. The y value of the vertex on a parabola is always involved in your range in some form or fashion. Okay? So yeah, no matter what, when you graph a parabola and you get the vertex, okay, parabola is a quadratic function, if you forgot the term parabola, okay? So when you have this U-shaped graph, whenever you find the vertex, the y value of the vertex is always involved with the range in some form or fashion. Since the y value of 0 is the lowest point, then it's got to be the number before the comma. On the previous one, the 7 was the highest y value. So that's why it ended up being the highest y value in the range. Okay? Yes, sweetheart. Well, you shouldn't be using square root. Well, you're just doing the square root of 5, which is just a number. There's no x's. This is saying y is equal to a number, so that's always going to be a horizontal line. Now, which one are you trying to graph? Okay. You're welcome, huh? You're welcome. All right. Moving on. Now, how was this one transformed? We know it was a vertical stretch. What did the 1 do? Because you got this in your homework. You got to decide to move left, right, up, down, and that stuff too. Yeah, this went right 1. This went right 1. I didn't do any of the horizontal stretches or compressions in homework. Okay, I made sure none of those were on there. So the x will always be an x. You won't have a parenthesis 2x minus something squared. It's always just going to be x plus or x minus in there. Okay, so I made sure I took those out there. All right. Transformations. The most simplistic quadratic equation, of course, y equals x squared, the parent function. Okay, this is known as the parent function. This is the way the teacher wrote their notes here. I just happened to talk quicker than what's there. A transformation is a change to the I think it's parent or original. I don't know. I don't know what the teacher was thinking about that one. Basically, we've learned that, hey, when we're doing a transformation, we're changing the parent function is what we're doing. Okay, we're changing the parent function in some form or fashion. So that's why on these next set, which is like you have for homework, we're practicing, hey, here's the parent function. So they gave us y equals x squared. And now I want to graph y is equal to quantity x plus 2 squared. And then say, how did it move? Okay, you can do the table and so forth. What's the vertex? Again, I would practice writing down the vertex. Now, it's the opposite. So it's negative 2 comma 0. Opposite of the inside. And then technically there's no 0 at the end. So so the k has got to be a 0. So the y value is a 0. Axis of symmetry, x is equal to negative 2. So I know negative 2, 0 would go in the middle of that table. And then now we're going to graph it, and we're going to grab stuff, and we're going to take a look at the picture to see how it changed. So go back to y equals. I'm just going to wipe out that whole thing. And we're going to go parenthesis x plus 2, close the parentheses, square that. And then I don't need anything. I don't need a plus 0. So I can just leave it like that. Hit graph. All right. So that shows that at negative 2, 0, there's my vertex. And then now, let me grab the table. So second graph. And we're just going to grab the points negative 1 and 0 and negative 3 and negative 4. Because they don't give me a big table here. So it was negative 4, 4, negative 3, 1 as an ordered pair. And then it was negative 1, 1, and then 0, comma 4. So as I do this one, again, I can plot all those. Those can fit on this grid here. So negative 1, 1, 0, 4. There we go, that side. Then we have negative 3, 1, and 2, 4. So there's my new altered version. Y is equal to x squared. The black graph is the parent function. How did it move? Did it move left or right? Yeah, it went left. How many? Yeah, so I'm going to say it shifted left 2 units. And a lot of these on homework are like drop downs. It'll say it did 2 units, or shifted 2 units, and then the next drop down will say left or right or up or down, and you just got to fill it in properly, okay, as you're choosing stuff. Now, where is the axis of symmetry? I actually keep forgetting because I told you I was going to do that. Here's the axis of symmetry. Axis of symmetry is, again, always goes through the x value, and so it's technically we represent it with a dashed line. Is what we represented with. X equals negative 2. Again, it goes through the x value of the vertex, and it folds it in half. It folds the right side over on the left side, or vice versa, is what it ends up doing. But again, it's an imaginary line, is what it is. So we don't do it as as a solid line. All right. What's my vertex on the next one? It ends in a +5, so that means it's got to be something comma 5. Yeah, it's 0 comma 5. So my vertex is 0 comma 5. Okay. So that puts me in the middle. Again, I like going by a scale of 1 when I do this just because it makes it easier to find it on the chart. Can you do it by a different scale? Sure. You just make it a lot harder on yourself. There are times when I would do it different, but that's when there's a fraction on the x. That's when I would go by something different. So now I'm just going to sneak over here. Y equals. We should already be thinking about how this was shifted, just to check ourselves. X squared and then just +5. Graph. That's what I was thinking off the top of my head. 1, 2, 3, 4, 5. I see that it was shifted up. And then as I get the table, second graph. All right, let's see. We got 6 and 9, and then 6 and 9. So I'm not going to get all those suckers on there because it doesn't go up to 9. But there's my graph. And then I can sneak over here and say that it was shifted up 5 units. Axis of symmetry happens to be the y-axis. My axis of symmetry is x is equal to 0. That's the axis of symmetry. So that happens to be the y-axis, which makes it tough to see sometimes. We just draw a little dashed line to highlight that a little bit better. Question so far? Now, what's my vertex on number 9? -1, 6. Thank you. -1, -6. -1, -6. And then now, before we graph it, how am I anticipating that it's shifting? Down 6 and left 1. So that's what my anticipation. Down 6, left 1. Let's see if I see that when I go to graph it. Parenthesis x +1, boom, quantity squared, and then I'm going to hit delete. All right, and then we get to do a -6. Hit graph. Yep, it went down and to the left. All right, so I know to the left 1, down 1, 2, 3, 4, 5, 6. There it is. I'm going to change colors. All right, so there is the vertex. I'm going to grab my table real quick here. Second graph. -1, 6, and then I could get to use negative. Whoops, sorry, wrong direction for negative. That should be 0 and 1, and then that's -2 and -3. So -2, -5, and -3, -2. And then it would be the same thing for those two. And I can technically squeeze all of those on there. And then there's my happy little face. Okay. And it did shift it to the left, and it did go down. Number 10. What's my vertex? Thank you. 4, 1. So 4, 1 goes in the middle there. How am I anticipating it to shift? All right, reflect over x-axis. What else? Up 1. It would be right 4, because it's a -4 on the inside, so it would be a right 4. That's what I'm anticipating. And then again, if we want to plot the vertex before even graphing it, we'd say, okay, if I go over 4 up 1, hey, yeah, that did go to the right, and that went up 1. Now I just got to make sure my picture shows that it's going to go down to the ground as I draw it. Okay, so my dots should be a bunch of negative y values is what I should see for a bunch of my y values. So then we go through here and then change that up a little bit. Remember, you got to use you can't use the subtraction sign for a negative. Got to use that little one, negative parenthesis, and then x minus 4 quantity squared, and then plus 1. Double check that I typed that in there right. Looks good. Graph. Woo, yeah, that looks pretty good. Second graph, get over here, get the table. I'm going to use 3 and 2 and 5 and 6. And that means I need to scroll down so I can get it all in my window. Oh, I got 2 of them being y-intercepts. 3, 0, 5, 0 being x-intercept, sorry. And then 2, negative 3. 2, negative 3, and 6, negative 3. So I cross here and here, there, and voila. It's opening down. It's been shifted. Looks pretty good to me. All right, we'll save the next two, 11 and 12. Let's go ahead and wrap this sucker up because we do have to do some of these writing equations. Those bottom ones are just extra practice. We don't have to do them. I always load a bunch of extra. Usually when I teach standard Algebra 2, I go through a bunch of those like one side just to give a lot of extra practice. Honors, we're expecting you to go quicker. So putting it all together, if you're given a quadratic function in the form of, in vertex form, y equals a times x minus h quantity squared plus k, h is the horizontal shift. It is the horizontal shift. If it's a plus sign on the inside, which way do I go? I go left. If it's a minus sign, I go where? I go right. Okay, so this is a nice little one to refer back to before you take your little 5-problem thing tomorrow. Okay, before we take a chapter test. Okay, K is the vertical shift. No matter what parent function it is, H and K have the same roles. Again, if it's a plus sign, then I move up. If it's a minus sign, then it moves down. If A is negative, so if there's a minus sign in front of the parenthesis, the function is reflected across the x-axis. Now, here goes back to when A is, when I take away the negative value on the A, and I just think about it being a positive number. If A is bigger than 1, then it represents a vertical what? Stretch. All right? Vertical stretch. If A is a proper fraction, that's what the next one's doing. If it's something between 0 and 1, then I have a vertical what? Compression. What was the other word we saw in the last chapter stuff? Yeah, shrink. Or we could use shrink. Okay, either one's fine. So proper fractions, so that's when I see 1/2, 1/3, 3/4. Okay. So that's a nice little thing to keep in mind and look at for all parent functions when we get their vertex forms. Okay. When we get the vertex forms for cubic functions, radical square root functions, and we keep doing more exponential functions, we keep that stuff in mind, okay? So, again, part of school is memorizing stuff that you need for several years. Once you're done with math, you don't need it anymore. Get rid of it. You're just not at that stage to get rid of it yet. Transformations from the parent function of x squared are described below. Write an equation that represents the function. So what you need to think about on this section is you think about the vertex form either in your head or write it down. And then now we look at this what they told us happened. I translated 2 units to the right. So 2 units to the right means there's got to be a minus sign inside the parenthesis because it's to the right, so there's a minus, and the 2 goes there. And then now they didn't tell me it did anything else, so now I can just leave the A be 1, the K I don't need on there because I didn't say it moved up or down. So I just put in 0 for the K. A is 1. We can't have A be 0 because if A is 0, then that whole problem goes away. Okay? Number 14, again, either mentally or physically write down what the vertex form looks like. They tell me that I did a translated 5 up, so K is 5. So that means a plus 5 at the end. Nothing else occurred. So that means it's x squared, and then it's y equals. So it's x squared plus 5 is the way it appears. Do I need the parentheses? No, we usually won't see it there, but I started writing it, so I went ahead and just kept going with it. Now, number 15, I see 2 things doing. I see it said 3 to the left. Okay, so y equals a x minus h, and then boom, 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 plus k. So it said down 4, so I know k is 4, and technically 3 to the left means that h is equal to negative 3 when we look at making the vertex. So now as I go to fill in, if I went 3 to the left, that means it has to be a plus sign with the 3. And then I have a minus 4, and sorry, I realized I just forgot the minus sign on the 4 up there when I wrote it. It's that being up at 2 o'clock in the morning, just catching up to Mr. Stevens. Don't forget to put the square there. Go home, make my wife supper, and then go to bed. Translated 7 units to the right and up 4. So when I look at my H, it is a positive 7. My K is a positive 4. I didn't do any reflecting or stretching, so that means I can go parenthesis, and then it's x minus 7. That makes me go right 7, squared, and then up 4, so plus 4. Again, we do, I don't remember if I put a bunch of these kind of ones on homework. We do find them from time to time on the end of course exam. That's why we're kind of putting them in here in the notes to look at. Number 17, I'm reflecting over the x-axis and translating down. So my h technically is 0. I went down, so k is equal to negative 3. And my a is a negative 1. It's a negative value because, again, it said I reflected over the x, which means it needs to be negative. Well, I can just use a negative sign, or I can use a negative 1 if I want to fill in. So as I take the vertex form, I have y equals negative 1 parenthesis x, and then squared, and then minus 3. And typically we would see that one. That one's typically going to be written as y equals negative, and then x squared minus 3. That's how that's usually going to be displayed. Because again, if we were finding the ordered pairs and I put in a value for x, I would square the x value, then make it, then multiply it by a negative 1, is what I ended up doing. Translated 5 right, 2 down. So my h is 5. My k is negative 2. And again, a has to be a negative 1 because it said it was reflected. So y equals negative parenthesis x minus 5 squared as a quantity, and then minus 2. I went for the cleaned up quick answer on that one. So, again, if you're ready just to write it like that, please write it like that, okay? I'm just trying to give you a foundation of how you can fill in the parts and go. Number 19, they say I have a vertical, it is vertically compressed. So A is 1/3. Translated up 8 units. So K is equal to 8. Since they didn't mention side to side, that means H has to be 0. So as I go to write this, y equals 1/3 x squared. I don't want any number inside with the x. And then I have plus 8. I'm thinking Big Ideas would take this as an answer. I'm thinking they'll take that as an answer. You can do either one of those two. Okay. I would go with the 1/3 as a fraction is what I would do. Okay. And then the last one we'll practice together, and I'll go back there and push out to make sure the time starts. Vertically stretched up by a factor of 2. So that tells me my A is 2. Reflected over the x-axis, so A also has to be negative. So that means that A is now technically a negative 2, so I'm going to get rid of that first thing. And then translated left 4, so H is equal to negative 4. They don't mention a K, so K has to be 0 for part of the vertex. So y equals negative 2 parenthesis x plus 4 quantity squared. And that's my final answer there. Again, remember, tomorrow we'll take a entrance ticket on.